Remainder theorem. Essentially what we're doing today is have two ways to divide polynomials using long division and then the shortcut method of synthetic division. But overall it's the same idea. We're just doing it over and over again. Our learning target for today is this right here. So I did my star in wrong order. Our learning target is at the end of the day, once we figure out how to do the actual act of dividing polynomials and binomials, this is what we should get. That when we divide a polynomial by a binomial x minus a, the remainder is the same thing as the polynomial evaluated at the point a. Okay, now, if we have a polynomial evaluated at that point and the remainder is 0, then we say that x minus a is a factor of p of x. In other words, I can also call it an x-intercept, or a 0, or a root, or any of those words that we have used. Okay, so if the binomial I choose factors out completely with a remainder of 0, that means I have found an x-intercept or a root of the equation, or a factor is another way of saying it. On the other hand, if the remainder is not 0, then it is not a factor, meaning it's not an x-intercept. The remainder, though, will still be the value of the polynomial at that point. Okay, so you can always check a number. If the original polynomial is 0, then you'll have a nice factor. If it is not 0, then you'll have a remainder of the value. Okay, we're going to do some examples here to help us with that. First, let's go back and review some of our terminology and vocabulary. When we use long division, we use p of x to represent the dividend. So the polynomial that we start with, p of x, is our dividend. We divide it by a binomial that we're going to call a divisor. And the result we will call Q for quotient with a remainder R. I'm hoping that all of these little letters and things, they all make sense. P for polynomial, Q for quotient, R for remainder. And the remainder we write as the number R over the binomial that we chose. Meaning we can't make this into a nice number because we don't really. We can always check our work by setting up the following equation. If we take our binomial and multiply it by the quotient, then add the remainder. Once we simplify everything into less-like terms, we should end up with the original polynomial. Okay. So in our warm-up activity, I said, what is 7 divided by 21,175? You said the answer, the quotient, is 3,025. So if I work backwards, if I take my quotient and the divisor, 7 times 3,025, it should bring me back to the original 5. Okay? So the divisor times the quotient, if there is a remainder after the remainder, should always give you back what you started. So these are essentially the rules of long division with some terminology in there. I'm also going to show you synthetic division, which is essentially a shortcut method of doing long division. A lot less messy, but it's doing the same skill, doing the same job, but we have to learn the full skill before we do so. If you don't understand how long division works, you mess up on the shortcut, there's no going back. Go ahead and check your work and figure out where you went wrong. Okay, so let's start with some examples here. Given a polynomial, here it is, 9x plus 4x cubed minus 12x. Let us divide it by x plus 2. Okay, so here is my p of x dividend, and my x plus 2 is my divisor. Okay, we want to express the result like this. Once we figure out what our numbers are, we'll set it up like it's going here. So first we're going to need to identify any restrictions, and we're going to write the corresponding numbers. If I am dividing p of x by this, so I have p of x is being divided by x plus 2. What is my restriction? X cannot equal negative 2 because, why is that a restriction? It's going to be 0 and we cannot have a 0 in the denominator. Okay, so always identify your restrictions. X cannot be negative 2 in this particular instance. Okay, next, let's talk about this box of information. Boxes will tell you these are important things. The order is really important when you do long division. We must write p of x from highest degree order, or in descending order. Okay? In order for this method to work, we need the degrees to start high and go low, because we are reducing the degree of due to long division. If we do them in the incorrect order, our zeros are not going to line up where we need them to. Okay, when you have degrees high to low, it helps us pull up the factors that we need in the correct order. The other thing we need to do is use coefficient of 0 for missing degrees. Okay, so if my highest degree is 3 as in this case, I need to have something for x. You need every degree to be represented. So in the equation, you can see there is no x squared. So I'm going to represent x squared as 0. Did I change the value of my polynomial? No, right? I've added a 0. Adding a 0 to something doesn't really change the effect or the result of it, but it will help you in terms of setting up this long division. So every degree must be represented. We rewrite the polynomial in order from highest degree to lowest, and then we start our long division. Now, zoom in here, and my handwriting is not very good on this tablet, so I apologize. I'm going to run out of room, but hopefully you guys have enough room on paper. When we do long division, we start using the same method that we did when we divide a polynomial with a modulo. I'm going to focus on the first term and let the second term worry about itself as we go. So I'm going to pretend that I'm taking 4x cubed and I'm dividing it by x. What would the quotient be? 4x squared. Okay, now when I write my line here, I have a binomial, meaning 4x squared has to multiply both terms in here to write my minus. Right? So I'm going to say 4x squared times x is going to give me 4x. 4x squared times times positive 2 is going to give me positive 2. So when I do the long division process, I'm doing it as binomial. But as I work it through to find the quotient, I focus on the first term. Okay? Now we minus. Minus here, minus here. What would my next line look like? 4x cubed minus 4x cubed, that's 0. Done with that. 0 minus 8 gives me negative 8x squared. And I bring down the next term, plus 9. Again, I focus just on the first term and the first term. What do I need to do to x to make it negative 8x squared? So I multiply it. This is 8x. Again, I multiply negative 8x by both my terms in the divisor. This gives me negative 8x squared minus 16x and minus 8. Negative 8x squared minus negative 8x squared, 0. 9 minus negative 16, what would I get there? No, minus minusing a negative. 20, 25. 25x, right? Because what I'm saying here is 9 minus negative 16. That's the same thing, 9 plus 6. Okay, bring down the next term. Again, focusing on just the first term, what is my quotient? What do I do to get 25? Positive. Again, I multiply both terms. This is my color here, 25x. 25 times 2 is 50. And I have to minus 7. So you're on the side. So here, minus 12, so negative 12 minus 50. Negative 62. I don't have anything else to bring down. So this is where I stop. This tells me that negative 62 is my remainder. Okay, so in order to write this in this format, this is the format I want. I did the left side for me. Here's my original p of x over x minus 2. Here's p of x, here's x minus 8. What is the result? The result, this is my quotient. This is going to be 4 x squared minus 8x plus 5. And my remainder. Well, my remainder is negative 62 over x plus 2. Because I can't go any further, but it's not done. Right? So there's nothing else I can do. So this is my remainder. Here is u of x, my quotient. Here's my remainder. Okay? Now we can check our work by multiplying the right side by x plus 2, and we should end up with the left side. We're not going to do that just right now. I'm just trying to show you the setup here, okay? So now on the next page, since division by 0 is not defined, then the divisor cannot be 0. So x plus 2 cannot be 0. So my resistance is that x cannot be 0. So I mentioned this on last week. So you have it later. Why is that a restriction? because the denominator. Okay, if I wanted to check my work, I would take my term x plus 2, multiply it by my quotient. This is 1 plus 25. I get x minus 8 times my quotient plus the remainder. If you expand both sides and very carefully collect my terms, this should give you the original equation. So when you use numbers for polynomials, the method of division along the same. It's a little bit misleading because numbers are very common. The method is essentially equation, or for example, 2, we have a word problem. The volume V in cubic centimeter of a given box is given by this expression. The height H is given to be x plus 3. What are the possible dimensions of the other sides? So what are the possibilities to the dimensions of the box? The other dimensions of the box in terms of that. Now, let's do some visualizing. Here is the box. Let's say that this is my length, this is my width, this is my height. What is the volume of the box? This times height. So we know the volume V, and we know the height H. Volume is represented by a cubic. If I take V divided by H, I'm left with LW. What kind of an equation should I expect from L times W? It would be a what kind of equation? The volume is a cubic. I divide the volume by the height. What am I left with? Square or a quadratic, yes. And if I have a quadratic, I can always use a formula or other way of solving it in order to find length and width in terms of the path. Okay? That's what we're going to try. So on here, we have the volume in descending order. We are dividing it by the height. And we're trying to determine what are the possibilities for length and width. So again, I'm focusing on the leading terms to help me determine what the solution is. So what do I do to x to get 2x cubed? What do I need? 2x squared. 2x squared multiplied by both of my terms is going to give me x cubed plus 6x. Let me write this. 2x cubed plus 6x. Okay, and then I minus them. Minus x here. Negative 5x squared, right? 1x minus 6x squared gives me negative 5x squared. And I bring down the next number, negative 27x. Okay, again, looking at the leading coefficient, what do I do to x? Get negative 5x squared. That's negative 5x. Negative 5x times x is 5x squared. Negative 5x times 3 is negative 16x. Then, this is 2 minus 2. So you be careful of the negative. This gives me 0, negative 27 minus negative 15. So it's the same as saying negative 27 plus 15 gives me what number? 12. Okay, and then I bring the next number down, minus 36. What do I do to x to get negative 12? All right, so this gives me negative 12x. Negative 12 times 2 is also negative 36. Hooray! Remainder is 0. That is what we wanted. That means we found the factor. That's awesome. So, here's how I'm going to write it. The volume now, which was this, is now going to be written as x plus 3, and it looks like I have a line break here, but we can add it in here. 2x squared minus 5x minus 12. So here is my height, and here is length times this. Okay, we are right. Can we figure out quadratic method? How do I factor this forward? What numbers do I need? I need two numbers that multiply to negative 24 and two numbers that add to negative 5. Say again. Negative 8, positive 3. Okay, in my shortcut method, if my leading coefficient is not 1, what do I need to do? Divide by 2. So that means I can further factor this into x minus 4. That represents negative 8 divided by 2. What about here? How do I write 3 halves? Okay, so here's length and width. Okay, so whenever we are factoring polynomial, our goal is always to do long division until we get it to a quadratic, because we know how to do a quadratic without doing long division. Okay, so now, zoom out here, the quotient, I'm just going to call it Q of x, that we found, represents the area of the base. So the factored expression is now x minus 4, 2x with a plus meter minus 3. And this represents the possible length and width of the box. So for all three, we have 3, 4, 2, you can use this dual application. Okay, can I see thumbs up, sideways, or down? How confident are we in this? Wonderful. Okay, let me turn this shortcut method. Okay, synthetic division is exactly the same process. However, we are focusing on just the coefficients of the column. It doesn't matter. I didn't say this is this way. This could also be like this one particular. Unless it specifies something that gives you more information. Okay, synthetic division is long division using only the coefficients of the polynomial and not worrying about the rest. The reason this is a shortcut is because if we understand how long division works, meaning whatever your highest degree is, When you divide it by a polynomial, you are reducing it. So if you started with an x cubed, your full sense is going to start with an x squared. Does that make sense? Okay, so that's the idea. So we're keeping the letters in our mind and not writing it down to keep it as soon as possible. Okay, so if this is our equation and this is our divisor, so this is p of x and this is x minus a, we want to write the dividend in descending order first. Let's rewrite it. Highest degree there is 2. So this is 2x cubed plus 5x squared minus x minus 6. I also check to make sure that every degree is represented. 3, 2, 1, 0. We're all here. So now I'm going to go to my next page. And I'm only going to write the coefficient. Okay, so just as a reminder, 2x cubed plus 5x squared minus x minus 6 divided by x plus 2. I start with my coefficients. Please pay attention to the negative. The only way you can mess these up is by either not adding and subtracting correctly or forgetting the negative. So I take my coefficients, 2, 5, negative 1, negative 6. Don't worry about the rest. The next thing I need is what is the value of x that I am dividing. This was a factor, x equals what? Okay, so x equals negative 2, we call the root of the value. So we're going to use negative 2 as our divisor. So I know there's a little bit of a typo in here, so can we just cross out these things here? We want negative 2, that is our divisor. And we are going to, again, typo right here, just to say half. Okay. So this is how it works. Coefficients of p of x goes here. The root goes here. And it will spit out the coefficient of q. The method is this. Drop the first number. Take the number and multiply it by the root. What's the root? Negative 2. So negative 2 times 2 is negative 4. Add up and down. What do I get? 5 plus negative 4 is 1. We check what we needed again. Again, multiply the root. What do I get? Negative 1 plus negative 2 gives me 3. Multiply the root. And then positive. Positive 6. Add these together, 0. Okay, so this is a lot quicker as long as you understand where I'm doing this from, right? When we did long division, we multiplied these together on the side. The goal is to make the coefficient equal to 1, which is done here. So my quotient u of x is going to be these terms, these coefficients, 1 degree down. So instead of starting with an x cubed, I'm now starting with an x squared. So this is going to be 2x squared plus 1x minus 3. Everything went down a degree. My restriction is that x cannot be negative 2. And that's pretty much it. We're done. That's the whole thing we want to do. Okay, so we can always check our work. So let me do this in quick form. You can copy this down if you want to, or you can just watch me do it. I'm going to do the same question using long division. Focusing on leading numbers, I want this to be 2x squared. So this is going to be 2x cubed minus 2 plus 4x squared. I have some minus these. And this gives me 0 here and 1 here. I bring down the column. Going to write this down. So x times x is squared minus x. And by minus these, this is 0, negative x minus negative 2x will give me negative 1 plus 2. Bring down the thing. How does it mean? What did I miss, guys? Oh, this one is supposed to be positive. All right? X times x is x squared. X times 2 is 2x. Positive. There we go. So then minus 1 minus 2 gives me negative 3x. What is it bring? Oh, you're good. I'm so sorry. Negative 3. So x times negative 3 is negative 3x minus 6. Here we go. So if I zoom out, we can see that my quotient here for long division after the quotient here is together. So no matter what method you use, your results should be the same. Long division and synthetic division. Okay. Let's back up to our learning target. Our learning target is to understand the remainder theorem. The remainder theorem says that if I divide a polynomial by a binomial, the remainder will be the same as if I evaluated that polynomial at that point. If the result is 0, I have a factor or an x-intercept. If it's not 0, then it's not 0. It's not a factor. So in our last example, I'm asking you to work backwards. Without doing any kind of division, can you tell me if, or what is the result if I take my polynomial, there it is, and divide it by x minus 3? What is my point of interest here? What is the root I'm looking for? X equals negative or positive 3? Positive. So this is what I'm interested in. So without doing any division, I should be able to tell you, is it an x-intercept or not? If it's an x-intercept, what should t equal? What should the polynomial be if you're at an x-intercept? 0. So when I put in x equals 3, t is 3 should equal 0 if it is a root. So let's try it out. If 3 times 3 to the 4 minus 3 to the 3 minus 5. Use calculator. Hold it. Think the number? Oh. So, what this tells me is x equals 3 is not an x-intercept. And if I did long division, my remainder should be 211. Let's use our shortcut method, synthetic division, to check if we did this correctly. So I'm putting in my polynomial in descending order using zeros to represent degrees that are not there. Okay, so highest degree is 4. Coefficient, 3. Next degree is 3. Coefficient, -1. Next degree is 2. Not see an x squared, so I put a 0. I do not see an x, put a 0. Last thing I do is my top. My closest interest is the number 3. That is my divisor. So what time please? Okay, step 1, drop the first number, multiply the root. What should I get here? 9. Add top and bottom. What should I get? 8. Multiply the root. What do I get? 4. Add top and bottom. 4. Multiply the root. 72, thank you. Add them together, 72. Multiply the root one more time. 26. Adding them together. But the last number is always the remainder. So we did it correctly. 211 is our remainder. Okay. Today's homework, we have about just under 30 minutes in class. I want you to save textbook homework for tonight. While we're in class today, I want you to either practice long division or synthetic division in Delta Math so I can track your progress. Okay? So until the bell, you choose long division or synthetic division level 1, level 2. You're aiming for 3 in a row correct.